No, you're gonna spin out of control.
Well,
He means it's all downhill.
You're gonna have no control of it whatsoever once you start going through.
it's all downhill from here, but we have no brakes.
Hey, whoa. Sam. I saw that.
Here's what it means.
Thank you. You spin out of control.
Of the 10 main units, we've already done 6. And a little bit of 7. So we basically have like 3.5 units to go out of 10. There's that. It means that we've already had 90 days of school and we have 90 to go. But of the last 90 days of school, about 25 are after the AP test.
Coolio.
It means we are closer to next summer than we are away from, and we're further away from the last summer. The days are getting longer now. If you went to Mexico, you're back from Mexico.
Oh, really?
That's over with.
Stop, you're making me all depressed.
He's in Mexico.
This all hit me on Saturday when I finished entering your grades. Like, well, yeah, I finished entering your grades. We're past the halfway mark. I'm closer to the next half. And I've been in such a good mood since like 12:45 on Saturday. Also, I'm dying, but whatever. Yeah.
You're not the only one.
Yeah, Hugo.
For the warm-ups over Mexico, what do we do with that? Was there
Find
any?
students that were here.
Okay. Oh, it's from Mexico.
No, you don't regret Mexico. Did everybody hear that?
Yes.
Country knows if you did not hear Hugo's question. Hugo said, what do we do about the warm-ups if we went to Mexico? And I said, you find somebody who didn't go to Mexico, Hugo. Yes, Caleb.
What do we do for the 28 days after the AP test?
Chill.
Chill.
I'm lying. We're doing a giant year-end project that's worth half your semester grade.
Awesome.
Should be.
Oh, yeah.
That's all of them when they have to
But I'm waiting because there's a lot of conversation going on. I want to make this a smooth break. Now that everybody's back from Mexico, and I'm assuming that you've all seen your grades, technically I could still offer you this afternoon if there was something that you absolutely had to fix about your grade. And so, does anybody have any papers for me, corrections, something to point out? I will be pressing publish on your grades today at lunch, unless you tell me otherwise. Is there anybody else that wants to do anything else about their grades? So your grade will be published today at about 12:05, 12:10. And looking over the first semester's grade book, I'd like to see if everybody can perhaps, it's a fresh start now, right? Semester 2, you're all starting from 0 in the grade book. So your grade is quote unquote reset now. A few of the lessons that I learned looking back at your grades that I would think you might want to learn as well. Number 1, the warm-ups are actually like kind of a big deal. In each unit, if you miss the warm-ups, you're talking about roughly 1% of your semester grade. You know these? That are like the most irrelevant, insignificant effort in the history of schoolwork. Basically, I'm giving you somewhere around 6 or 7% of your grade in exchange for trying to force you to just open your binder when you get to the class. Because you all know how much of a hassle it is when the teacher has to wait for that one student to get their game together. Or those 2 students? Or those... Okay, thank you. Like, I want to check in on the grading strategy stuff here. Like, the warm-ups. They are just a way to get you thinking about something that I'm going to answer later. So when we're all running out of steam at the end of the period, we already got the question out of the way. But keep in mind that the points are designed so that they're such easy points. It is just such low-hanging fruit that I really hope everybody will have their binders open at the beginning of the period every day. Yeah?
Oh, are the, all the bills due for the Mexico deal?
Yeah.
Right.
Second, the extra credit. Now that the semester's behind us, I've done a few analytics on the kids from the first semester. And the extra credit is kind of frustrating and depressing for me. Fun fact, students who have really low grades in my class usually don't do the extra credit either. So I want to do it as like a last resort for the kids that are failing, and statistically, the kids who really, really fail, they don't do the extra credit anyway. That might be why they're failing, because they're too busy, or that might be why they're failing because they're not motivated by grades. Here's the other part of that fun fact. More than half of my extra credit points are totally pointless. Kids with A+ get higher A+ with their extra credit. And again, this might be why they have A+, because they're really focused on grades, so then they do the extra credit just to get even more focused on grades. Or they got nothing going on in their lives, so it's like, yeah, whatever. I'll do all the homework and study 6 hours a day, and I'll go to the extra credit. But somewhere in that extra credit equation, there's a few students who really leverage it, and I want to talk about that strategy. There's a bunch of kids, probably 15 or 20 in my entire grade book, whose letter grade was up by 1, and there's a couple kids whose letter grade up went by 2 because they do a lot of extra credit. I have one student who does all the homework, all the classwork, and she does really poorly on the exams. And she just takes all the extra credit. She goes to all the movies, she turns in a bunch of articles, she does the things on the weekend, she did the winter break reading quiz. That student, she's in another period, her grade would probably be like a very high D, low C. And I think that she was right on the fence between a high B and a low A. I can't remember where she landed. That's pretty badass. The extra credit really does work. And I know that a lot of your availabilities will change with fall sport, spring sport things. But remember that you've got choices. You can go see the movies. They're usually not the most suffering in your life. You can turn in the article submissions. You can pay attention in class and be like, I'll get that for you. Whenever there's a question in class that we've had like a number that I'm always just like, and I'll tell you, like I'm not really sure the exact, you can be like, I'll get you the exact. Like students that are just attentive in class will send me emails and bring me papers that are relevant to my lectures. The things that the Green Club does, they're not horrible. They're like nice places to be with like cool people. I hope you'll really consider the extra credit if you weren't quite satisfied by your grade last semester. A lot of kids missed it by this much, like right off the pole there. And finally, like missing work is like such a downer for my students. Perfectly timed. Do you guys notice that control right there? Sneeze control.
Notice how there's Kleenex right there?
Oh, no. A, no, I didn't. But B, you look away from the light and you hold the sneeze. And you look at the light. Sneeze. Okay.
Is that going to be on the AP exam?
Missing homework can be a severe handicap, and for the couple of students who actually missed an exam and didn't make it up, that's like a letter grade. Like, do not miss an exam. There were 6 in the last semester. There's only 4 in the coming semester. So each exam is worth a bigger share of your semester grade. All right. Anything else about the first semester, the grading and the strategies? Like, I want to do this like optional conversation moment just to get everybody like back into the beginning of the semester mode. Anything else about this? Anybody have a question? Like, I never really understood how the you go.
So semester 2 starts with chapter 7. Right?
Yep. So a lot of the work that you did in the last few weeks will carry over. We've already done, an assignment and a half. We're going to finish another assignment today, maybe. And we're like starting with what we've already done. But yeah, first semester done. What else? Other questions? Yeah.
Are we going to have a final in second semester?
We are, and so we have 7, 8, 9, 10. Technically, Unit 11 is a sheet of paper, like one assignment that we will discuss in class in like 1/2 day, and the Unit 11 quiz is like a sheet of paper. It's just a quiz. So there's basically 4 units. Then 2 weeks of review. On the last day of review, you take a final so that you're ready for the next Monday's AP test. And after that, we've got like 5.5 weeks of the year-end project, which is a class-wide project where everybody here works on one thing. Okay. What else? Yeah.
So our house plans are due tomorrow?
Next Tuesday.
Next Tuesday. I just saw that, and I was just sitting here like so dope.
I was kind of thinking, dang, sweet, I got nothing to do tomorrow. Like, so the house plan is easy for me. Okay.
Next Tuesday.
Yeah, that's next.
There's no.
Dang. You got 7.5 due tomorrow, though.
Oh, shoot. Oh, that's good. Shit.
What else? What else? Nothing else? We're all ready for the second
I
semester?
like your treatment.
Yeah. Yeah. Fine. I hate your questions anyway. Yes.
Oh, what was the score on the test?
I don't remember. Maybe 35?
Oh, no, that can't be.
You did? You sure? Maybe that was it.
You should have summoned in this class for tomorrow.
Oh, well. You go to Mexico? Yeah?
Yeah, I just wanted to.
You want people to know what you got? You want people to know what you got? 36.
They like tolerate other
What's the test out?
30.
Well, there were 44 graded questions. The curve was set at 30. So Homeboy got 120%.
The curve was just 30 for this class, so what was like the highest curve in all the classes?
No, that's across all the periods. So we threw out the top like 16 scores or 15 scores. 15 scores. All right. I think we're done with getting ready for the semester, and we're all like, we're here? Okay. Okay. I want to do a heads-up 7-up vote, so people around you don't see what you're voting. So if you don't know how a heads-up 7-up vote works, you put your foot down, you put your elbow, and you raise your hand. And you're going to keep your head down for a minute, so get comfortable here. Please raise your hand if you would like to change seating arrangements. And please put your hand down if you are comfortable discussing this in open discussion with the class. So people with their hands up just don't want anybody to know that they want a new seat, is what I'm saying. Oh, bingo. Then you can all look up. You know, I don't want your friends to hate you for leaving them or whatever. So, as usually happens, everybody in the front feels perfectly good being up in the front, and as usually happens, by the end of the semester, people in the back are like, it's really hard to take notes for here. So, we could either give them the ability to take a seat from somebody else, or we could ask for voluntary switch out, where some of the kids in the front want to go to the back. Or we could just randomize things, and we've got about a minute to decide how we will handle this. For me, the easiest is to just randomize. Find the most fair.
Why not just say who wants to wait? Why not just say who wants to go forward?
Yeah, voluntary doesn't work.
Well, it depends how many people want to go forward. Yeah.
All right, fist fight for the front seats.
Did you say naked Rochambeau? Oh, naked Rochambeau, yes. Yes,
Naked Rochambeau. Gotta do it without any clothes on.
Can we do a count who wants to move forward and then see? I don't know.
Well, there were like almost everybody in the back 2 rows wants to move.
Okay, everybody in the front want to move?
Everybody in the front's like, no, this is cool.
Alright, yeah, it's randomized.
No, well, is there anybody else?
Anybody in the front voluntarily want to go to the back?
Even if I did, there's still
You both raise your hand. Where do you want to go?
I realized that I shouldn't have raised
Same
my
with me,
hand.
If we don't have 2 rows that want to move back, then we should just randomize.
I thought it was going to be like if the majority wanted to change, it'd be randomized. I don't want to like.
That was kind of an impulse thing.
Well, I hope everybody understands the fundamental challenge I have to address. That everybody should have an equal chance, and of course, having a natural advantage is fine as long as it's your natural advantage. But when you recognize that it's forcing other people to have a disadvantage, then we should probably
Let's just randomize it then.
Yeah,
find some way to fix this.
Even
Isn't there something on the
back
computer?
3 rows to the front 3 rows and vice versa.
No, because then we're still with the same people. How about just like?
We could do a perfect switch. Yeah. We could do a perfect switch, or we could just randomize.
like I'd give up my seat, but there's not 2 rows that are going to give up seats, so why even give up
Yeah,
my
I just want like a
Kids in the back.
change. Like nothing against you guys. I just want like new people. I want to have the same
taking it personally.
Fuck you, Caesar. I don't want to sit next to you either.
Randomized.
How many of you will vote for a switch up?
Wait, what is that?
Makes sense because you're all in the back, so you don't get better.
Let's randomize and see who wants to move after that.
How many people want to do it?
We could just share the front seats, like 3 people to each. Yes.
Everybody in the back. All the back 3 rows, they all want.
Can we just change the
Just
The
randomize.
advantage is really hard to give up, isn't it?
compromise?
Keeping it rank, I just like push all the desks forward into
2
one.
rows that are going to give up that same.
Mirror it.
Randomized.
Russian roulette.
Sit in the back.
I think the person who dies doesn't need anywhere to sit.
We're all going to have a fight to the death right now. Just sit in the back.
That's 3 shots.
Jose, isn't there like a button on the computer where you can just randomize it?
Just randomize. It's easier. I think it's been past a minute too, so.
Yeah, so like, I hope you all see the obvious implications for social justice and what this says about our material world here.
This was just a test.
Yeah, exactly. It's nobody about your money, actually. I actually think that the fairest thing
Would be to switch out.
would be to mirror each row.
Well, you know what? Life is
What about the people?
So if you've had the best seats for a whole semester, then now you should have the worst seats for a whole semester.
Let's do that. Yeah.
Then like the middle is probably best. It's like
You can't see the.
Hey, yeah. What about the people in the middle?
like voluntarily if some people like
Or you can
Right.
randomize
like
it.
if they're like, oh, I like the back and they want to go back to the front, then like then they can do that, but then like
Or we could randomize it.
Yo, Cedar, you weren't at Mexico, right? The warm up.
All right. I know that this is going to hurt. I know that this is going to hurt. I am trying to give everybody an equal share of the gain, which means I have to give everybody an equal share of the pain. And so for the first round of this negotiation, we will mirror front to back within each row, and then we can trade seats.
All right, I'm dropping this box. That's a lot
Front row party.
I've already traded.
It's like a beat you up there.
And now, while you still have all your bags packed up, I'm totally open to anybody trading. I just don't want us to take all day. Yeah.
I'm in this class.
Yeah, transferred it.
Alright, anybody want my seat? I want to change.
What do you want to change? Ah.
I'll go anywhere. I'm already in the back.
Anybody want either of those?
Oh, I thought.
You like split?
No, I said Hugo and Cedar should start.
James, Mel, you like it back there? Nobody wants to sit next to James, huh? Isn't that weird? All right. So this is what we get. Anybody in the back, or you can get one seat closer and take the one next to Hugo. Never mind. Nobody else? Oh, good times. It's very important that tomorrow everybody holds these seats, because I haven't actually made final seating cards. And I'm sure this burns, but you know, like everybody else has been getting burnt all semester, so they're kind of used to it now. All right. Let's finish 7.3. Please take out your 7.3 notes. All right. In this unit, we've already talked about some basic fundamental energy physics, foundations of energy. Then we talked about fossil fuels, petroleum, extraction, natural gas, fracking. We talked about the global consequences of the petroleum trade. And maybe that's where we left off on what was study goal number 23, or did we get all 12 parts of study goal 23?
We got 11.
We got 11?
No, we got all 12.
We got all 12.
I got 11.
8, 9.
Number 12 was after we have all the impact of getting the petroleum, then at the last step we actually burn it and cause the global warming. So let me see if I can clear this up then, and then we'll move on. Your book had 8 global impacts of petroleum extraction. I added the oil tanker problems, the challenges of petroleum refining, what we call fractional distillation, and I added the transportation hazard of moving all those products across the map. Then number 12 was the part that everybody talks about, how burning fossil fuels has climate and air pollution consequences. And the point I was trying to make with this list is that in conversations of the petroleum world, everybody wants to discuss the CO2 and the global warming and maybe the smog. But even if you give away the whole concept of CO2 and global warming and air pollution, there are still a lot of devastating consequences to the petroleum industry. I'm hoping to broaden the conversation beyond merely number 12 to all the other stuff that happens before we light it on fire. Did we talk about ANWR in this class, the Arctic National Wildlife Refuge? Yes? Yes. And have we talked at all about coal? Number 25? How many of you saw this diagram last week and a half ago? Great.
What's that?
Now I'm done asking questions and I'll start giving content. Kind of a lot of conversational noise here. Making my hands into fists, you know. Okay, so you need to know that there are 4 grades of coal: lignite, subbituminous, bituminous, and anthracite. And there are a couple of different spectra drawn in this image. So let me show you what I'm saying, and then you can start to copy. But it might be good for you to know what I'm saying. And by the way, I have a whole bunch of snow peas. If anybody's into, we just picked these in my garden this morning, so you can all help yourself if you want. All right. Watch this. The different spectra. From lignite, subbituminous, bituminous, and anthracite, you're going, please look up, from low to higher pressure, which makes more and more carbon bonds, so also from lower to higher energy content. And as you squeeze it more and more, that's getting rid of the water. So, more heat and pressure means more energy content and less water content, thus less impurities. Yeah, bituminous. And these are all vocab terms that you should have had in this assignment. And this diagram was posted, I believe, before Mexico, so I had hoped most of you had it. I know some of you did, so it's kind of curious that the rest of you don't. Yeah?
For the diagram that was on 4, he was on the side, said heat, but like, what's the definition?
This is peat. Peat is like really fine plant material. It's basically the... so Am I the only person that's noticed that if you step on horse poo, it's just like ground up pieces of straw? Have you all noticed that? That like, horse poo is just straw, like held together in a clump? Okay, so this is the cricket version of horse poo. This is ground up little pieces of grass fibers. Cricket poo? Like, this is not actually cricket poo. This is not cricket poo. It's not cricket poo. I mean to say this is like the scale equivalent. These are little tiny pieces of grass fiber. So whenever you have a grassland and a river that washes that grass into a swamp, at the bottom of the swamp you get this. It's not cricket poo. It's like other stuff that has been eating and abrading, and rocks will mash together. Shut up. The worst person.
Yeah.
It's sterile. I mean, it was sterile before I touched it. It's not dirty. For this lecture. It's labeled Unit 7, P. Alright. Yeah.
Wait, so the ones on the left side of the drawing have less pressure and less energy, and the ones on the right have more pressure and more energy?
Yeah.
Did you say there were less impurities on that side?
The Here comes your short answer. The impurities are usually water soluble, so by squeezing out the water, you usually wash away most of the impurities.
So there's less water in the...
Less water, smaller droplet, and thus less impurities. Technically, by the way, people who did very careful homework know that anthracite has slightly more impurities than bituminous coal. Why is that? It's about other stuff. It's not the main impurities that matter to us. Something to do with metals. Yeah.
Wasn't bituminous having more impurities than all the other ones? But it was just the most common?
I think it might go the other way. It has the least impurities. No. Lignite had the most?
Come on.
Yeah, I think lignite has the most. I think this actually has the least, and then they go back up a little bit.
No, that's not what I wrote. That's not what I did. There was a chart in the...
Here, I don't doubt you. I've always been befuddled by this. This is not the newest edition of the book, but it's fairly new. Will you check for me? Let's just settle this for the nerds. Yeah?
So I'm just confused. What is the EF energy?
Okay, so let's see if I can answer Hugo's question. That might help us all get back on track here. CO2's in the air. Using sunlight, plants fix that CO2 into sugars as a way to store energy in carbon bonds. Coincidentally, plants do other stuff with that CO2 as well. They make other carbon bonds that are not sugar. They are structural carbon bonds, primarily one called lignin. That's the name. Lignin is the structural carbon framework that supports woody growth, plant growth. It's basically what makes trees tough. Okay? Lignin is a carbon bond that holds together plants. Now, when plant pieces are left on the ground, they are remains of life but now dead, right? They still hold lignin. It's a very tough carbon chain. So, by taking plant material and compressing it, you make shorter carbon chains into longer carbon chains. And by pressing it more and more, you're making them into bigger and bigger carbon chains. This is the building of fossil fuel energy. You're aggregating carbon bonds.
This is coal before it's compressed.
So that's pre-coal. If you squeezed that, you would get a coal nugget about the size of your, like a small fist, smallest fist in the class. And then if you kept squeezing it, you would get smaller and smaller coal with proportionally less overall impurities per unit volume and more energy content per unit volume. Yes.
Might be a little bit off topic, but like, how does the coal transfer into a diamond to become like a clear little shiny thing?
So it's not actually coal that makes diamonds, it's ash. And so it has to be like just a very narrow, I don't know, nerds. Leprechauns do it. Something about voodoo and like Marilyn Monroe or something. But yeah, so I'm pretty sure that the geologic precursor of diamond is ash. And I'm pretty sure that there's something about like very, very high compression in like exceptionally denuded environments. It's like literally just carbon. And I don't know how to do that.
So can you burn diamonds?
I don't think so.
I
I mean,
it makes sense if it's just
you say yes?
chains of carbon.
I think not. Yeah, but it's not actually, it's like hydrocarbons, though, so there has to be hydrogens attached to those carbons for them to make fuel sources.
Isn't petroleum just hydrocarbon?
Yes, but it's not just carbons.
Oh, it's just carbon.
Diamond is just carbons.
Oh.
Hydrocarbons are
Okay,
fuels.
okay.
Yeah. Yes.
How do you compress plants? Like what you're talking about non-carbon?
Like bury them under sand and then put more sand on top and then put more sand on top and then put more. So it's like sedimentary.
Okay. And then also for the less impurities, is that one related to like water content or is it related to like the pressure and energy content?
So I gotta admit that there are unfortunately a lot of details that A, I don't know, and B, aren't really part of our class. The impurity question is a tricky one. Here's what I can tell you. The main impurity that everybody talks about with fossil fuels is the CO2. We all agree. Carbon, 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 carbon. Okay. That is a byproduct of burning the fuel, but that's not what we're talking about impurities here. When there's dead stuff, it'll have other parts of the dead stuff, like DNA has not just carbon in it, and inside your cells there's a lot of carbon bonds, but other stuff too. Some of those, in coal, the main one that we worry about is SOx. You know what the X stands for, everybody? It represents an integer, like X in algebra. So that's SO1, SO2, SO3, and SO4. Those are called the sulfur oxides, plural. So SOx. Everybody got that? SOx? Like SO1, SO2, SO3, SO4? Okay. Gabby, the biggest impurity that really affects quality of coal is the SOx you get when you light it on fire. How much sulfur was in it? But there are other impurities too, like nitrogen oxides, NOx. There are heavy metals, and probably a variety of other stuff I can't think about that I don't know. And so the general trend is this one, Gabby, that impurities go down because most of them are water soluble. So it's like squeezing out a tea bag. You know, like as you squeeze it, you're getting rid of water, but stuff's going with the water, right? So like after you wring out a tea bag, you've kind of gotten rid of much of the tea content, right? So a lot of the impurities go away as the water goes away. Technically, per unit volume, there's like a little pickup in some impurities on the tail end. Correct me? What? No. I asked you.
All right. Well, do you want the numbers?
Yeah.
Okay. So anthracite is 97% low sulfur, between 0 and 1% sulfur content.
Okay.
Whereas bituminous coal is a 29% low sulfur, 26% medium sulfur, and 43% high sulfur of over 3%.
Okay.
Whereas subbituminous coal is 99.6% low sulfur,
Whoa.
and lignite is 90% low sulfur.
Okay. So the dirtiest for sulfur is this one,
Yeah.
right? Okay.
Which also, looking at this map of America, it
Yeah.
appears to be the most common in relation to its energy content.
And we do have that one. I have that map coming up in our slideshow. Maybe other impurities, not just the sulfur. Yeah.
So you're saying that like water holds the impurities?
That's weird.
Most of them. Apparently, just not the sulfur.
Okay. Wait, so that the bituminous
Bituminous has the most salts.
Okay, so it's just like that special circumstance is not the.
Like, I know that the general trend is this one,
Yeah.
decreasing impurities, but SOX that we really worry about, that seems to be the most concentrated in this one.
Are we
And
going to know that, or just?
I'd say hard for me to be sure.
Okay.
Yeah.
Well, I mean, there would be a trend of decreasing impurities, but subbituminous is actually less impure than anthracite, but only slightly.
Collapse.
Yeah, no, I mean, that, exactly, like that, I have to admit, this has always confused me about how the SOX and the other impurities are not on the same graph. Yeah, I think SOX is an exception to the other impurities.
Yeah, I mean, I thought it was confusing, but then when I tied it into the map, it sort of made sense because you have like, you know, there might be a graph of the rarity of them as well as a graph of how much energy they produce in the impurities, and then like between those three, it makes sense that like we're using more of the impure coal.
Right. Because we have the most of it.
Yeah.
Okay. So I apologize for the confusion of the impurities, but I hope the general trends make sense. Starting with the partially digested plant material, we squeeze it. More squeezing makes more energy content and less water. The spectrum is lignite, subbituminous, bituminous, and anthracite. And now, quick little review of the history of coal in the U.S., which actually has a few interesting details, and I know that this is one of the classes that has more students that understand history and politics, so this might be interesting for you. Check it out. First fun fact, coal use in the United States goes at least to the 1300s, way before Whitey. The Hopi pottery makers used coal. They had, by the way, coal mines and coal trade, and they had like roads of like coal trade networks. As the Industrial Revolution was leading to military superiority throughout Europe, finding a colony in another continent with that one key resource was a really big whoop. Keep in mind, when Belgium moves to the Congo, they can't keep doing the Belgium thing very well because it doesn't translate too much to the Congo. But when England moves to the United States, what a lucky coincidence that the one key ingredient of their economy was also discovered here in the U.S. If you look at the size of the map, England is pretty small compared to the United States. You can imagine the obvious geopolitical value of the American colonies for the European colonizers. So we started commercial coal mines in the U.S. before we were an independent nation. One of the biggest hopes for the United States would be that it would become a source of industrial expansion for the European colonial states. Unfortunately for Europe, the United States sought its independence, and early in our American history, we caught up with Europe. Early in the American history, we were like, hey, the European nations did pretty well with this coal thing, maybe we can too. And really, I think our country was really lucky to have those resources at that time. Any graph of United States economic growth overlays very cleanly with the growth in the coal mine volume, especially the first 150 years of American history. The size of the American economy was precisely tied to the volume of coal mine. until the early 1900s. The United States is really famous. How many of you have heard of vertical integration and horizontal integration? Did you do this in your economy? Dodson does this or something?
No, in history.
Gannon does this. Okay, great. You all know that horizontal integration is what we call an industry monopoly, like when somebody sells all the coffee cups. But vertical integration is a lot more challenging usually. And the number one historically most vertically integrated empire was this guy. And a lot of people don't really realize how remarkable that was. He had some coal mines, so he started buying land. So he started to really monopolize the mines themselves. And within each mine, he had like a lot of little economic twerks that really let him get the most for his buck. So he owned the building where the miners worked, and he owned the store where the miners would buy their food. So he had like pretty tight ship in the mines. But then he started to buy up the steel mills that were using his coal, so he could have his own tools manufactured and his own train tracks manufactured and his own trains. So he literally like used his coal and his steel mill to make his tracks where he would run his trains shipping his coal.
So he's running on his coal.
So basically, exactly, his idea was, I want to go from the raw energy resource and the raw material resource all the way to the consumer. Yeah, and actually, like, you know, essentially he would enslave America because all the economy would be his, except for people just moving his money to him. And so, coincidentally, like, if you guys want to, if you're into the economics of this guy was a fairly remarkable, ambitious, crazy, evil genius.
Is he maniacal?
Maybe. I mean, maybe brilliant, maybe just like, you know, cutthroat. Maybe, I don't know. People called him King Coal, and you should know, please, that today King Coal is the industry, but historically, King Coal was that guy. Like, it was a name for a dude that today is the industry. It's also an interesting fun fact in history that the first power plant was a coal-burning power plant. And the crazy thing is, if you look at the basic design of Thomas Edison's first power plant, you might be surprised to know that most of our electricity is made in plants that are conceptually the same. Mechanically, we've got a lot of cool gadgetry and power plants that are more modernized. But basically, the first idea of how to make electricity is the main idea of how we make electricity right now. Most of this electricity comes from his idea. Slightly tweaked a little bit. If y'all are into labor history, labor law, unions, mommy-daddy unions, union rep types, whatever, unionized labor, the history of unionized labor like really was launched by the coal industry. Historically, there was a whole flurry of labor disputes around coal mines, massacres, federal intervention, the first assembly line conveyor belts to get to replace workers, huge like skirmishes between employees and thugs and workers, and pretty interesting. But you know that in the early what? Question? Sorry. You know that in the early 1900s, there was a new energy found in the United States. We really got excited about the natural gas and petroleum. And it really looked like coal was done for. Like, this coal is so hard to get, and it's so heavy. And you pop a hole in the ground, and the petroleum comes squirting out. And so leading into World War II, it really looked like we were going to quit coal. So much effort, like hard rock mining for energy, instead of just getting liquid out of the ground for energy, or gas out of the ground for energy. And then, when the deadliest air pollution in the history of fossil fuels, right at the end of the world, you guys know that London is like a really foggy place. There's a clothing company called London Fog. That Jack the Ripper could hide in the fog across the street. It's like surrounded by water. I'm glad you laugh at this. It's not too soon. We're cool. So like London's surrounded by water. There's like a big channel, like big body of water this way, big body of water. So there's always fog moving. So London's always foggy. Okay. Do you guys know what happens when you mix smoke and fog? You get snow. Fog.
Clouds.
And so apparently there was like a few days there where people would like walk to work, and before they got to work, they would like die in the streets. like really bad. Like thousands of people, literally like thousands of dead people. And so, you know, like there was this thing called World War II, and then like England did like a little bit of rebuilding. And so in 1952, you know, England was really hustling to like recover from World War II. And their economy was ramping up, and they had a lot of social development projects going on, and so they had a lot of steel milling, and a lot of energy making, and a lot of, I don't know what the hell they were doing. And so everybody burning all this coal at a moment when there was really dense fog, and basically they made this like toxic cloud of smog that killed thousands of people, and all over the world when everybody heard about it. If you ask your grandma and grandpa, they'll probably remember this. It was a big deal. Since the whole world heard about this, everybody was like, okay, that's it. No more coal. We transition. There's this natural gas. There's this petroleum. And so for the next 20 years, it literally looked like coal was over. You got to admit, it's kind of like some crappy old stuff. When the United States started to manage its air quality, the coal industry just went, oh, dang it, people care about the air. And like, the coal industry was dying. Seriously, air regulation means killing coal. You can't really, they don't go together. But then, do you remember why Volvo developed the LCP 2000? What oil? What oil crisis?
Prices went up.
Why prices go up? Embargoes in the 70s, Middle East, right, yes. You know, it's on the board. The 1973 oil embargo, mostly I think it was Iran, but maybe I'm wrong about this. Like a couple of the OPEC producers were having some internal issues, and so they had to hold on to the petroleum, couldn't produce as much for sale. The rest of the world goes, holy crap, we're running out of petroleum. And in the United States, we did something else really well in the early 1970s. We figured out that you could blow up the top of the mountain. Instead of sending little black lung blind mole rats into the mountain, you know, like it can't breathe, mining, like chip, 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 trying to get the... Instead of trying to find that one little vein of coal inside the mountain, we figured out a new technology in the United States. Why don't we just blow up the friggin' mountain? It's called mountaintop removal. And strategically, it's a very elegant solution. You know, people are expensive. There's all this like liability crap. All these like freaking rights. Dan Obama. And so, rather than spending all this money to keep people alive while they dig these expensive little holes underground, it's actually really easy to just blow up the mountain, scrape away the dirt, and you're left with a clean, exposed layer of coal on the surface now, on the new surface.
It's really the American way to blow it up.
And coincidentally, this, like, we can all laugh, but coal has been winning because of this concept my whole lifetime, and certainly your whole lifetime. Like, coal just went from the energy of the past to the energy of the future in 1975. And we've just been watching it for 40 years, like, yep. Yeah.
All because of the oil embargo?
Well, it was a perfect confluence. You know, coal was going, and then oil embargo, and then mountaintop removal, and then everybody was still making new stuff, and, you know, air emissions was making it harder, but then, dun 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 dun. I guess what